好的，多谢王老师，感谢各位大家来一起来分享我们的这个活动啊，不好意思啊，因为我没有注意到这个是一个中泛论坛，所以我这个还是按照英文来准备的，所以我想我还是按照英文的方式向大家进行一个简要的汇报。Hello everyone, my name is Zhou from Southeast University of China. So my presentation today is about the influence of occupant behavior on the efficiency of the solar domestic hot water system. There are 4 parts in my presentation. First, it is about the research background. Solar domestic hot water system plays an important role in energy saving and emission reduction. In China, 21 provinces require the installation of solar hot water system in residential buildings, and the number of solar hot water systems in operation have reached 300 million square meters in 2020. So currently, for the solar hot water system design, as shown in the table, only the daily water consumption is considered. However, in fact, the daily hot water consumption behavior of users has different distribution over time, and the energy of the solar hot water system also changes with the sun throughout the day. Therefore, the distribution of water usage for occupants may have an impact on the solar hot system. Previously, studies have found that occupant behavior has a huge influence on the building energy consumption, while the impact of users' water usage on solar hot water system is rarely discussed. Therefore, in this study, we want to figure out how occupant water usage will influence the solar hot water system design and how to optimize the design and to improve the operation by using occupant energy conservation. The research approach is shown on the slide. Based on the literature review and field measurement, this study established an information-driven stochastic model of occupant water usage. This model is interaction with the solar hot water system model through parameters such as water consumption and hot water temperature. Based on this model, the optimal design of solar hot water system to match the user's actual water usage and to match their occupants' awareness of energy saving were studied. Based on field measurement and survey data, we came up with an information-driven stochastic model of occupant water usage. As this figure shows, at each time step, based on the current water usage type, the number of remaining bath time, the water consumption amount was determined by 3 stochastic modules. Meanwhile, an information-driven module was added into the model, as presented by the blue dashed box. This module is used to reflect the occupant's response to the signal provided by the system. So the users will adjust their water usage time or amount according to the information provided by the solar hot water system. Then a centralized storage and terminal gas reheating system was taken as the studied solar hot water system. The equipment selection of the system and the control logistics of the pumps were listed in the table. The specific model calculation method is detailed in this reference. And the 2 models are interacted through water consumption and hot water temperature in the centralized water tank. At each time step, the water usage model will output a total water consumption amount to the solar hot water system module. Meanwhile, the solar hot water system can offer a temperature information to the users. Then users can choose whether to feedback according to the temperature signal. Through the comparison between the simulated water usage and the measured data, we can find that the model can reflect the actual distribution of occupants' water usage. Meanwhile, the simulated and actual performance of the water solar hot system during this period was compared to validate the interactive model. The comparison of effective heating, heat loss by pipes and the tank between simulated and measurement is shown in the table, and the differences are within 10%. So it is feasible to use the model to analyze the performance of the system in the next step. Then we come to the case study part. There are 4 cases were studied. The basic setting is shown on the slide. In case 1, it is a basic case, which is designed according to the current standard for solar hot water system. During the design process, only the daily water consumption was considered. In case 2, the distribution of actual water usage was taken into consideration. Namely, users use more water at night, so the heat storage should be increased before the peak of night water use, and the impact of water replenishment should be reduced. So the water tank volume was reduced, and the water pump would keep the amount of water in the tank full during the day to store as much solar energy as possible. Then case 3 and case 4 were designed to check the influence of water temperature feedback on the system consumption. In the 2 cases, the solar hot water system provides the information about the water temperature in the tank. And when the water temperature reaches 45 centigrade, a certain percentage of users will respond to the temperature signal, and there is a certain probability that they will take a bath immediately after receiving the signal. So based on the actual water usage profile, we made improvements to the solar hot water system design, including reducing the water tank and changing the control logic of the water pump. From the comparison, we can find case 2 can reach a similar solar energy utilization while saving the investment cost. A typical day was chosen to take a close look at the operation of both systems. We can find that in case 2, before the peak of water consumption at night, the water tank stores enough hot water for night use, so its supplementary heat at night is even smaller than case 1. Then we compared case 1 and case 3 to figure out whether the water tank temperature signal can produce energy saving effects from the standard designed solar hot water system. From the annual solar energy usage ratio, it can be concluded that the improvement is very limited. So we also take a typical day to figure out what happened. According to the water volume curve of the water tank and the water temperature change profile, it can be found that during the huge capacity of the water tank, the hot water is sufficient for users at any time of the day. That is to say, the amount of hot water supply in this typical day is much greater than the demand at any time. Therefore, the water usage curve has no obvious effect on the operation of the solar hot water system. So the temperature signal feedback cannot work in this system. Then to the improved system design, we found that the involvement of the user's feedback also cannot work. The reason for this is that the offer of temperature signal leads to a water usage peak around 2 o'clock in the afternoon. However, due to the limited water tank capacity, the solar energy cannot cover all the demand. Therefore, many terminal reheat was consumed during this time. Namely, the mismatch of supply and demand causes signal feedback cannot bring energy saving effects. Based on case 4, we further studied the impact of users' energy saving awareness on the use of solar energy. This figure describes the solar energy usage ratio in a typical day varies with the proportion of responding users and the probability of users' response. It is interesting to find that in this typical day, under a certain feedback intensity, the supply and demand of the solar energy system can be better matched, thereby retrieving a higher solar energy utilization. Of course, this matching relationship will be influenced by the system design and the water weather condition, which is one of our further research topics. Well, then I want to make a summary about this presentation. This study, an information-driven stochastic model of occupant water usage was proposed. This, which is integrated with the solar hot water system to reflect the influence of water usage profile and users' response. Based on actual water usage profile, the water tank capacity can be reduced, which can save investment and achieve the similar operating effect as the standard water tank design. Due to the surplus system capacity for the standard designed solar hot water system, providing fee-based signals to users cannot achieve system energy saving. Whether the solar hot water system can exert its energy saving potential is affected by the coupling of water use behavior and the system design. On one hand, it should stimulate the energy saving behavior of occupants. On the other hand, the system should be able to match the energy saving awareness. Well, then that's all of my presentation. Thank you. 我的报告大致是这样啊，就是欢迎各位老师如果有想要交流的随时跟我联系。然后感谢主持人，感谢组委会啊。
好，谢谢周老师，谢谢周老师带来的这个关于人的这个使用行为对太阳能热水系统反馈影响效率这样的一个分享研究。那么我们后面的话在讨论环节再向周老师请教。好，下一个报告人是